All right, folks, let's take a look at WebAssign number 17. It says find the indefinite integral by the method shown in example 4. I have no idea what the method shown in example 4 is. However, I do know this is a lot like the 4 pepper problems that we looked at in section 4.5 in the notes. So let's go ahead and start by letting u equal x plus 6. Why did I choose x plus 6? Because that's the inside piece of that function right there, that part of the function. So I go ahead and differentiate here, and I get du equals dx. And now I want to go back to the integral and see where we're at. Okay, so this piece right here is u to the 1/2. I'm in good shape right there. Dx and du are equivalent, so I'm in good shape there. But now I have a problem with this x that's sitting outside here, because I have to restate that in terms of u. I can't leave it as x if I'm going to substitute all the x values out for u values. So what I need to do is a little bit of transformation of my u substitution. If I subtract 6 from both sides, I get that x equals u minus 6. And that is going to be what I substitute in to this expression to get rid of x. So let's go ahead and rewrite this in terms of u. So I need to take the antiderivative of the quantity u minus 6 times the quantity u to the 1/2 du. And this would be great, but there's a product right there. That's one quantity times another. And both of those quantities are variable, and we should know by now that we do not have a product rule for antiderivatives. So we need to go ahead and distribute. We're going to multiply u to the 1/2 by both u and -6. So that'll give me u to the 3/2 minus 6u to the 1/2. And that is now a sum or difference of functions, and I can take the antiderivative of each, and I'll be in good shape. Okay, from this point, I'm ready to now make my substitution back in terms of x. And remember, I hope you weren't lost by this. 6 times 2/3 is equal to 4. 6 times 2 is 12. 12 divided by 3 is 4. So just wanted to highlight that for you. So let's go ahead and substitute back in terms of x. We're going to have 2/5 times the quantity x plus 6 to the 5/2 power minus 4 times the quantity x plus 6 raised to the 3/2 power plus my constant of integration. And that was a couple weeks ago, I would have called that a 4 pepper problem. Not anymore, folks. We've become immune to this degree of difficulty. This is now just a 1 or 2 pepper problem. Gonna make one last comment. It says here, referring back to the method shown in example 4, that refers back to our textbook. And if you look back in the textbook, or if you choose practice another version in WebAssign, you may see an answer that looks significantly different than this. That's because they've done, at least I know in WebAssign, they do some more simplification there. They factor out an x plus 6 to the 3/2 power, and then they factor out a constant, and they do some more simplification beyond that. But I assure you that this answer is complete and correct. One last comment here. If you are really looking for a 4 pepper problem, what I'd encourage you to do is try to take the derivative of this and show that it equals x times the square root of quantity of x plus 6, the original integrand. That is without a doubt a 4 pepper problem. Good luck.